When a bullet is fired, pulling the trigger releases a hammer or striker, which strikes the firing pin, igniting the primer at the base of the cartridge. This spark then ignites the gunpowder, causing rapid expansion of gas that propels the bullet out of the barrel with force, creating the gunshot sound. The rifling inside the barrel spins the bullet for stability during flight. A bullet is a projectile. If you want to try this with an aluminum or even a square-shaped bullet, you'll be targeting yourself, or worse, even your hand. This is why the production process is typical. You get an understanding of how bullets are made. This will give you an insight into both the science, effectiveness, and the extensive effort manufacturers put into ensuring their reliability. And in this video, we are going to discuss this. It's a step-by-step process. Please watch to the end, it will be interesting. Firstly, you got to pick the materials used for bullet: lead, copper, brass, steel, and sometimes tungsten or polymer coatings, depending on what the bullet is typically made for. Lead is the most common. It is used mostly because of its high density, which allows for a greater impact force, and its malleability, which makes it easy to shape. But since lead alone is too soft for high-velocity shooting, manufacturers encase it in a harder metal, like copper, to improve its durability and minimize fouling in the firearm's barrel. Copper and brass are also used in bullet jackets and casings because of their corrosion resistance and strength. Some specialized bullets, such as armor-piercing rounds, incorporate hardened steel or tungsten cores to maximize penetration. In recent years, lead-free alternatives have been developed using bismuth, copper, or polymer to reduce environmental impact, particularly for hunting ammunition. Once you have gotten the materials you need, the manufacturing process begins, and this starts with the creation of the bullet core. This step is important because it determines the bullet's weight and balance, and this, in turn, affects its accuracy. To create the core, lead ingots are heated to extremely high temperatures until they become molten. The liquid lead is then poured into molds, where it cools and solidifies into cylindrical shapes known as lead billets. Though some people do this differently, some extrude the molten lead into long wire-like strands. It is then cut into smaller pieces called slugs. Each lead slug is then passed through a series of dies in a press machine that gradually shapes it into the desired bullet form. If the bullet is a simple, unjacketed lead projectile like a revolver or shotgun round, the process is nearly complete at this stage. But for jacketed bullets, which are common in rifles and semi-automatic firearms, more steps are required to encase the lead core in a copper or brass shell. These jacketed bullets are actually important. They are designed to provide an enhanced durability, reduce barrel fouling, and improve aerodynamics. The process of making a bullet jacket starts with thin sheets of copper or brass. These sheets are fed into a stamping press, which cuts out small circular discs. Each disc is drawn into a shallow cup shape through a progressive series of dies, slowly elongating and refining the metal shell. Once the jacket reaches its proper dimensions, the lead core is then inserted. The combination is then subjected to extreme pressure in a forming press, ensuring that the lead fills the jacket uniformly. This process prevents air pockets or inconsistencies that could affect performance. The jacketed bullet may be given a pointed tip for improved aerodynamics or left open at the top for controlled expansion upon impact, as seen in hollow point bullets. After the bullet core and jacket are combined, the projectile undergoes another further shaping to make sure it meets exact specifications. Precision is critical in bullet design, as even minor variations in shape, weight, or balance can also affect its accuracy and trajectory. During this phase, the bullets pass through a swaging process, where they are pressed into their final shape. Some bullets, like boat tail rifle rounds, are designed with a tapered rear to reduce air resistance and improve long-range performance. Others, like wad cutter bullets used in target shooting, have flat noses for cleaner holes in paper targets. Also, some bullets are coated with special lubricants or polymer coatings to further reduce barrel fouling and enhance performance. At this stage, bullets may also be subjected to crimping or cannelure processes, which involve adding small grooves or indentations to ensure a secure fit within the cartridge case. A bullet alone is not enough to fire a shot. It must be part of a complete cartridge that includes a casing, gunpowder, and a primer. The casing is typically made of brass, aluminum, or steel, serves as a container for all components, and ensures the safe ignition and ejection of the round when fired. The assembly process starts with inserting the primer, a small but varied component located at the base of the cartridge. The primer contains a tiny amount of explosive compound that ignites when struck by the firing pin. Once the primer is in place, the measured amount of gunpowder is poured into the casing. The exact amount varies depending on the type of ammunition and its intended use. Too much or too little powder can affect velocity and pressure, potentially leading to misfires or dangerous malfunctions. Finally, the bullet is inserted into the open end of the casing and crimped in place to ensure a secure fit. Some high-powered rifle rounds may also undergo sealing processes to protect the gunpowder from moisture and contaminants. Before ammunition is packaged and distributed, it must pass rigorous quality control tests to ensure reliability. These tests include 1. Weight and dimension checks. Every bullet is measured and weighed to ensure uniformity. Even slight inconsistencies can affect accuracy and performance. 2. Live fire testing. Random samples from each batch are fired in controlled environments to assess consistency in velocity, accuracy, and function. 3. Ballistic gelatin testing. Some bullets, particularly those designed for self-defense or law enforcement, are tested in ballistic gelatin to evaluate their expansion and penetration capabilities. 4. Pressure and velocity analysis. Sensors and high-speed cameras are used to monitor how the bullet behaves upon ignition, ensuring it meets performance expectations. Only after passing all these quality control measures do bullets get packaged and shipped for commercial, military, or law enforcement use. There are many types of bullets, each designed for specific purposes. Let me explain briefly each of them. 1. Full metal jacket, FMJ, a lead core completely encased in a copper or brass jacket, used mainly in military and target shooting applications. 2. Hollow point, designed to expand upon impact, making them ideal for self-defense and law enforcement. 3. Soft point, features a partially exposed lead tip for controlled expansion, often used in hunting. 4. Armor piercing, made with hardened steel or tungsten cores to penetrate armor targets. 5. Tracer rounds, contain a chemical compound that burns brightly, allowing shooters to see the bullet's trajectory in low-light conditions. 6. Frangible bullets, designed to break apart on impact, reducing the risk of ricochets. These are commonly used in close-quarters training environments. The process of making bullets is a precise blend of metallurgy, physics, and engineering. From selecting the right materials to forming, shaping, and assembling each component, manufacturers follow strict guidelines to ensure bullets function safely and reliably. Advances in bullet technology continue to improve performance for military, law enforcement, hunting, or competitive shooting. The next time you see a bullet, remember that it is not just a simple piece of metal. It is the product of decades of research and refinement, designed for precision and efficiency. Thank you for watching. Please don't forget to like and subscribe for more interesting content. We have other videos on our channel for you. Choose the left or the right video and enjoy.